Hello everyone, welcome to Aryan tutorials on engineering mechanics. So in this video, I would like to explain about worm gear screw jack, which is one of the types of screw jack. So here I would like to give a simple definition, okay, which is very simple. Here the worm gear screw jack is defined. That means it is a modified form. Okay, it is defined as a modified form of a simple screw jack, which is designed to further increase the velocity ratio for improving its performance. So in the same way, by using the differential screw, how we have improved its ratio, that is the velocity ratio. In the same way, we can increase the velocity ratio by using the worm gear mechanism. So that here I would like to explain that thing. So next step I would like to tell you the worm gear screw jack works on a principle of worm wheel mechanism. So however the worm wheel works for power transmission, so in the same way it will work. So basically we use the worm gear, that is the worm screw and worm wheel for power transmission in between the two perpendicular non-intersecting parallel shafts, sorry, non-intersecting perpendicular shafts. Okay, so I would like to show you here. And again, one more step is here, the worm gear drive is used for transmission of the power between the non-parallel and non-intersecting shafts, just now I told you. Next I would like to show you the image. So here this is basic representation, which is the basic figure which will show the worm gear adjustment, that is the worm and worm wheel. Here this screw part is called as uh, worm screw, and this is called as worm wheel or worm gear. Okay, this entire mechanism is the worm gear mechanism. So next I would like to tell you, I would like to show you the figure, exact figure for worm gear screw jack. Okay, this is the figure for worm gear screw jack, which will be consisting of worm screw, worm wheel or worm gear, okay, which is mounted on a particular element which will be having internal threads, and it which is mounted on the main screw of the screw jack. Okay, based upon the rotation of this worm screw, the worm will rotate, okay, which will be rigidly fixed. So when the worm wheel is rotated, this nut element will be rotated. So when this element is rotated, same, at the same time this screw will move up and down according to the rotation. Okay, now just like a screw and nut mechanism, only because of the nut is stationary, the screw will be moving above and below of the nut. So based upon the rotation of this worm screw, the worm wheel rotates, and this worm wheel rotates the nut. According that, the linear motion of the screw will be taking place, on which we will be placing the required object that is to be lifted. Okay, so next so see, this is the simple diagram I'll show you, I am showing here. Okay, so this is the worm screw, and this rectangular part is worm wheel, and this vertical screw is the main screw which is related to the screw jack body, and this is the nut. Okay, and this is the screw head on which we will be placing the weight that is to be lifted. And here, rather than the lever, on the lever a wheel is provided. So this wheel will be rotating by applying certain effort. So when you rotate this wheel, automatically the rotation of the screw, which is the worm screw, takes place, which causes the rotation of the worm wheel. So according to that, the movement of the uh, screw, that is the screw of the screw jack, takes place in upward and downward direction. Okay, now, so now step by step I'll tell you what are the elements we need to consider for analyzing the performance of the worm geared screw jack. So first I want to tell you it consists of hand wheel, worm, and this is and sorry, uh, worm and worm wheel, screw and a nut. So basically worm geared screw jack consists of hand wheel, this is the hand wheel. Okay, next worm and worm wheel. So this screw is called as worm, and the worm wheel is worm gear on which the screw is mounted, and the screw and nut, this is the main screw, and the nut, into the nut the main screw is inserted. Okay, basically in the actual instrument the nut will be placed in the worm gear only. So when you are mounting the worm gear, that worm gear will be mounted in a nut. So into that nut the main screw will be inserted. So through that nut the main screw will be moving up and down according to the rotation of the worm wheel. Okay, so next let us assume first hand wheel radius. So there is a hand wheel, so in the figure the radius is represented as a small l. So assume the hand wheel radius as small l, Next, the pitch of the screw, pitch of the main screw, which will be moving up and down according to the rotation of the worm wheel. So the pitch of that screw I want to assume it as small p. And next, the number of teeth on the worm wheel. So we need to consider the number of teeth. Why we need to consider, I tell you. So the number of teeth on worm wheel is equal to assume as capital T. And next, the effort is applied on the wheel as capital P, and the load to be lifted as capital D. Okay, so these elements we need to assume for analyzing the velocity ratio and mechanical advantage, then the efficiency of the screw jack, which is the worm geared screw jack. Okay, so in the next video I will tell you what is the exact working of the worm geared screw jack. So here I have given the sentence, read carefully. So I am reading, listen. When we rotate hand wheel through one revolution, so this is the hand wheel. So when we rotate this hand wheel through one revolution, the worm, which is the screw, worm screw, rotates or pushes the work wheel, that is the worm wheel, by one teeth. So when you complete one rotation by this hand wheel, that means this screw, worm screw, that is the worm, also completes one rotation, but the worm wheel rotates through a distance of one teeth. Okay na? So it will push equal to one teeth only. So it means what? So when the worm wheel completes one revolution, it will cover all the teeth, but here the worm wheel is moving only related to one teeth, means so throughout the pitch value. So when it complete one revolution means it will complete one pitch value. So it is covering only one teeth, means so throughout the P it is covering only one T. So that means, so throughout the revolution it is covering only one teeth. Okay, so that means what here? It means the wheel and screw rotates through 1 by T of revolution. That means 1 by T of the pitch of the screw as well as pitch of the worm also. Pitch of the, not screw, pitch of the nut in which the screw, main screw is moving up and down. Okay, how it will be? I'll show you now. So how means, the total number of teeth on the worm wheel, whatever the number of teeth it is having, that will cover one revolutions, means pitch value of the wheel and screw. So all these number of teeth on the worm wheel covers one pitch value, that means one rotation, which covers the one revolution, means which is pitch only. Pitch means for one revolution how much the distance it is covering. So automatically, so the number of, total number of teeth covers the pitch value of the wheel as well as the screw hole. Sorry, not screw, here we need to mention the nut. Okay, so one, that is the pitch value of the nut, it will cover. So here I will give again relation. So total number of teeth means cover the pitch value of the nut in which the screw is inserted, and L is the, 1 for one teeth. For number of, total number of teeth it is covering one pitch value, means so for one teeth how much the distance it can cover, means that should be 1 by T into P, means P by T. So that means when you rotate this one wheel, okay, when you rotate this wheel through one revolution, the screw will pushes the wheel to one teeth. So that means it will move 1 by T of the revolution. So that means 1 by T of the pitch value of the nut, okay, as well as 1 by T of the pitch value of the worm wheel. So that means automatically it is covering 1 by T of the pitch, means during one revolution, the one revolution of this wheel, the load moved by this P by T of the distance. So after a number of revolutions, the wheel will be completing one rotation. That means after completing all the teeth, all number of teeth it is covering, means then it will be moved upward direction or downward direction equal to the pitch value. But here during one revolution of this wheel, it is pushing only one teeth. So that means 1 by T of pitch of the nut, the rotation of, that is the displacement of the load, will be taking place here. Okay, that is only the is the main thing based upon the working of the worm wheel. Okay, which will intensify the velocity ratio for the screw jack, that is the worm geared screw jack. So that means here this P by T will be the, during one revolution how much the distance moved by the load. Okay, so remember this P by T, which is very very important. Okay, next, so this distance moved by the load, so automatically during one revolution how much the distance moved by the load, means P by T only. Okay na? So when it is completing p by t of revolution means the distance will be also moved p by t of revolution only. Okay, so that is equal to, we can write it as p by t, that is the distance moved by the load during one revolution of this wheel. So next I would like to tell you what is the velocity ratio. Velocity ratio, already we know the definition as distance moved by the effort, that is the p, during one revolution of the hand wheel by distance moved by the load during the one revolution of the hand wheel only. Okay, so the distance moved by the effort is how much during one revolution of the wheel. It will cover the total circumference value of this wheel based upon the radius we have assumed. So L is the radius, so 2 pi L of the distance will be covered by the wheel during one revolution by the distance moved by the load is p by t. So write it as p by t. So modifying the equation, we will be getting 2 pi lt by p, which is the velocity ratio for the worm geared screw jack. So remember this velocity ratio, which is 2 pi lt by p. L is the radius of this hand wheel, and t is the number of teeth on the worm wheel. Okay, and p is the pitch of the nut or worm wheel, we can consider. Okay na. So sorry, p means here pitch of the nut only we need to consider. So according to the pitch value of the nut only, the distance will be moved by the load. Okay, so small p is the pitch of the nut in which the screw of the jack is inserted. Remember that thing. Next, if the worm and worm wheel unthreaded, so this formula is for single threaded. Single threaded means during one revolution, okay, it will cover only one thread. Okay, again when the worm or worm wheel is given with double threaded, so during one revolution of the hand wheel it will cover two teeth. Okay, now two teeth means it will be again distance moved by the screw in vertical direction will be uh, p by 2t. It will become p by 2t. Okay, now whatever the analysis we have applied for total number of teeth, it is covering pitch value. So for two teeth, how much the distance it will be covering means automatically we will be getting, sorry, 2 p by t we will be getting. Okay na, 2 p by t we will be getting. I'll show you here. So based upon that, we'll be getting the formula as 2 pi lt by np. Okay, we'll be getting 2 pi nt by lp. Why? Because the distance moved by the load will be np by t. So np by t means the t will be again moved to the numerator. Okay, then 2 pi lt by np. So this n related to the how many number of threads it is having, or how number of starts it is having, single start, double start and triple start, like that the threaded worm and worm will be manufactured. So based upon during one revolution it will be covering two teeth or three teeth or four teeth. So based upon that we can take the formula for the velocity ratio. Okay now, which is the velocity ratio when the worm and worm wheel are n threaded. So remember this equation also, this is for single threaded and this is for n threaded. Okay, so next we go for mechanical advantage, which is defined as the ratio of load lifted by effort applied. So w by p we can write it as w by p. Okay, next as well as we need to write the efficiency of the worm gear screw jack. Efficiency is equal to, we know the ratio of mechanical advantage by velocity ratio. Okay, this is the efficiency. So finding the velocity ratio is very important in the improved form of the simple screw jack. So because why? Because we'll be uh, designing these two special types for intensifying the velocity ratio only. Okay, once we know the velocity ratio and mechanical advantage, we can find out the efficiency. So next I would like to discuss one simple example. So according to that we can understand how to solve the problem also. Here a problem is given: a worm geared screw jack has, sorry, that is has screw jack has the following specifications, like hand wheel radius as L is equal to, sorry, hand wheel radius L, and I'll show you the values. So L value is 300 mm and pitch value is 10 mm, and T number of teeth are 50, and the effort applied is 100 newtons, and the load to be lifted is 100 kilonewtons. Okay, so with this information, if the worm is double threaded, so here given the thread of the nut or worm is given as double threaded, find the efficiency of the jack. We need to find the efficiency for the double threaded or double start worm and worm wheel. So write the same data given. Okay, so in this, if the worm and worm wheel is n-threaded, the formula for velocity ratio is 2 pi lt by n into p. So in this, 2 pi is constant, into L is 300, into T is 50, by N is double threaded, so 2 into P is the pitch value 10 mm. So modify or simplify by using the calci, we'll be getting 4712, which is the pure number dimensionless quantity. Okay, remember this value. Next we go for finding mechanical advantage, which is equal to W, load to be lifted, by effort to P. So load to be lifted is 100 kilonewtons, means into 1000, by effort applied is 100 newtons. So 100 will be getting cancelled. Next mechanical advantage is equal to, as it is 1000, which is pure number again. Okay, next we need to find out efficiency of the worm gear screw jack. Efficiency formula is mechanical advantage by velocity ratio. Mechanical advantage is 1000 and the velocity ratio is 4712, we got in the previous slide. So by this we'll be getting the value as 0.212, which will be equal to 21.2%, which is the efficiency of the worm gauge screw jack. Okay, so this is about worm gauge screw jack, which is again further improved form of the simple screw jack for intensifying the velocity ratio. So please try to concentrate on the worm gear mechanism, how the one rotation of the wheel causing the movement of the wheel through one teeth only. So throughout the pitch value, it is covering one teeth, means so the distance covered by the load will be equal to P by T only. Throughout the P, it is rotating 1 by T only. So 1 by T into P will give you the rotation, that is the distance covered by the load during that particular rotation. Okay, so that is about the worm gear screw jack. I hope you understand. If you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video, and please subscribe and please share my videos with your friends. And once again, thank you all.